Alright guys, this should be a little bit of review, but hopefully it'll kind of stick and you guys remember this stuff. But this is lesson 13.1, representing sample space. So you're going to use lists, tables, tree diagrams to represent a sample space, and then you're going to use a fundamental counting principle to count outcomes. So what we have here is one red token and one black token. They're placed in a bag, a token is drawn, and the color is recorded. It is then returned to the bag and a second draw is made. Represent the sample space for this experiment by making an organized list and table for a tree diagram. Alright, so an organized list. So the first time you could have picked a red, and then the second time you could have picked a red. You could have picked a red and then a black. You could have picked a black and then a red, or you could have picked a black and a black. Because each time, possibility is just one of those two. And that's it. That's your organized list. Now, a table, you have your outcomes, and you have red, black this way, and red and black this way. Okay, so you, red, black, red, black, or black, red, I guess. Sorry, my fault. So black, red, and then black, black. So write this one down first, and then the top one. And then the last way could have been a tree diagram. You had your outcomes, and the first time you could have picked a red or a black, and then after that the red could have had a red or a black, and then the black could have had a red or a black. So possible outcomes would have followed from that. Red, 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 black, black, red, or black, black. Okay, each time there's 4 outcomes and different ways to do it. Table's kind of neat. You probably don't see that one very often. Tree diagram I know you've seen, and just listing them I know you've seen. Alright, so here we have a chef salad at a local restaurant. It comes with the choice of French, ranch, or blue cheese. So you have your dressing. It's French, ranch, or blue cheese. And then you have these optional toppings. Be careful on this one. It's not saying you get to pick one topping. You could have all the toppings. So for the cheese, it could be cheese or no cheese. For turkey, it could be turkey or no turkey. And for egg, it could be egg or no egg. So this one's a little different because you get to choose between each of them whether that's what you want or not want. Okay, whereas a lot of them, it says you get to pick one topping. So we want to construct a tree diagram to represent this sample space. So I'm going to start out saying, this one's going to be a little large, so careful here. We have French, ranch, and blue cheese. And then from each one of those, we have cheese or no cheese. And then from each one of those, we have turkey or no turkey. No turkey on that one, sorry. Started looking like a C. And then from each one of those, we're going to go and have egg or no egg. Oh, I knew that was going to happen. It's going to run into each other. This is bad. I don't want to redo it. So I'll just move it out farther. And so from this turkey, egg, no egg, egg, no egg, egg, no egg, And last one, egg. No egg. Whew, that was a doozy. Okay, so we took each possible one. I like the color thing because then I can see where it's coming off and that there's branching off there. So that's a tree diagram for your sample space. So this sample space, just so you know, it has 1, 2, 3, 4. 4 stages. So the first stage was the dressing. The second stage was the cheese or no cheese. And then turkey or no turkey, and then egg or no egg. So 4 stages. So you have 4 times to choose things. So let's look at this next problem. We're at a baseball game, the bleachers at a major league game. You can purchase a hot dog, bratwurst, or tofu dog. Okay, so that's stage 1. So we have the kind of dog that we're going to have. And this comes with the option of the choice of ketchup, mustard, onions, or relish. So each one of these, remember, it's not that you only get to pick one. Okay, there's a difference. It's saying that each time you can choose to have ketchup or not ketchup, mustard or not mustard, onions or not onions, relish or not relish. So you have a hot dog, a bratwurst, and tofu. You have ketchup, no ketchup, mustard, no mustard, onions, no onions, relish, no relish. Okay, so how many stages are there? There are 1, 2, 3, 4, 5. 5 stages. So this is going to make things nicer. So the fundamental counting principle, what it says is that the number of possible outcomes in a sample space can be found by multiplying the number of possible outcomes for each stage. That's the key here. So whereas on the hot dog one, we had 5 stages, and then you multiply the number of outcomes from each. So remember, just thinking back just a minute ago, okay, we had the hot dogs. There were 3 choices there. And then there was ketchup or no ketchup, so there was 2 choices there. And then mustard or no mustard, onions or no onions, and relish or no relish. So 2 choices, 2 choices, 2 choices, 2 choices, 3. So we multiply all that together, and then we will get the the number of possible outcomes that we could have had. So just picking this hot dog, okay, we have 48 possible different hot dog combinations that could have happened. So it says we're going to just multiply them together. Stage 1 possible outcomes, stage 2 possible outcomes, stage 3 possible outcomes, and then just multiply them all up for each stage. So here we go. Let's apply this. New cars are available with a wide selection of options for the consumer. One option is chosen from each category. One from each category. How many different cars could a consumer create in the chosen make and model? Okay, so our first stage is exterior colors, and we have 11 choices. The next stage is interior color. We have 7 choices. And then the next stage would be seat material, 5 choices. And then engines, 3 choices. Computer navigation system, 6 choices for that. Wheels, 4 options. And doors, 3 options. Multiply all that together, and the possible number of consumer cars are 83,160. So there are 83,160 different possible cars that could be made. All right, last one. How many different bicycles could a consumer create in the chosen model? So options, stage 1, colors, 9. Stage 2, gear shifts, 3. Seat material, that's stage 3, 3. Stage 4, brakes, 4 choices there. Stage 5, handlebars, 2 choices there. Stage 6, tires, 3 choices there. Stage 7, pedals, 2 choices there. Multiply that all together, we get 3,888. Okay, that's it. So be careful, you're looking at stages and the number of choice in each stage. All right, get going on that homework.